Okay, so this video is going to cover problems 51 through 60 of the death packet. This is problem 51 through 60 of the death packet, and we are starting with problem 52. So suppose P is 0.6 and P is greater than 0.6 is the alternative. So essentially they're saying a proportion has a value of 0.6 or a proportion has a value greater than 0.6. And we're going to learn more about proportions later. So I'm not too concerned if you're struggling with this now. Against the alternative, the proportion equals 0.7. The power is 0.8. Which of the following is a valid conclusion? This is very actually poorly worded. It truly is. And so what I guess I want to say this is they're saying this is actually what it is. This is the actual value. So the claim is this is the claim. It turns out, so this is the actual claim, and we could just call it mu, but it really turns out reality is it's over here at 0.7. This is what reality is. And they're telling us power is 0.8. Which of the following is true? Well, first off, we should be rejecting, okay? We should be rejecting because the power, because this is true and this is false. Power is 0.8. And please remember that with power, there is a formula that we have, and that's 1 minus beta. So in this case, 0.8 equals 1 minus beta. So beta equals 0.2. And beta is the probability of a type 2 error. All right. So if this is true, the probability of failing to reject is 0.2. And remember, beta is the probability of a type 2. So failing to reject would be 0.2. So this answer is 52. And I'm going to put this on pause because I'm expecting. All right, so we are, gosh, is this, I can't tell if it's recording. It says it's recording. So which of the following is a true statement? We're on number 55 of the death packet. And please remember, power is a conditional probability. Type 1 error, type 2 error, and p-value are all conditional probabilities. So which of the following is a true statement? P-value is a conditional probability. It's given. Given the null is, and a p-value is given that the null is true, what's the probability we get a test statistic this extreme or more extreme? All right. So because it's a given statement, and remember, a conditional probability just means that we're going to have some sort of given statement. Okay, looking, I was asked to go back to page, look at 53, so I'm going to go ahead and do that because I'm not that far away from it. A company will market a new hybrid luxury car only if they can sell more than 50,000, otherwise it will lose money. They do a random sample of 50 potential customers and run a hypothesis. They can sell it for 50,000 or the alternative greater than 50,000. What would be the consequence of a type 1 error? Well, remember, so our null is this, our alternative is, so this is our null, and here's our alternative. A type 1 error, we rejected, so that means we believe this when in fact this is true. So what happens if I believe it's greater than 50,000? Well, if I believe it's greater than 50,000, I'm going to start producing the cars. So I'm producing the cars. It turns out remember it's an error, so I believe this, that was wrong. It's less than 50,000, so that means I'm losing money. So I chose to produce a car that that wasn't profitable. So type 1 error, produce a non-profitable car. What's a type 2 error? A type 2 error is failed to produce. So basically, I believe it's 50,000 when in fact it was more than 50,000. Because I believe there's only going to be 50,000, I didn't produce it. So I chose not to produce a car that would have been profitable. So 53 should have been A. So we're on 56, question 56. If all variables remain constant, which of the following will not increase the power of a hypothesis test? All right. So as we increase beta, alpha goes down. So alpha, beta is a measure of type 2. So as we increase this, as this increase, alpha goes down, which is a measure of type 1. But it was asking will not increase the power. So power equals 1 minus beta. Well, as this value gets bigger, power goes down. So as beta goes up, power goes down. They move opposite of each other, and they are actually formula. So if we increase this, power goes down. And they said which will not increase power. So that one's C. They move opposite of each other. All right, on number 57, given that the power of a significance test against a particular alternative is 96, so power is 0.96, which of the following is true? Remember, power equals 1 minus beta. So that means beta is going to be 0.04. And that's the probability of committing a type 2. And type 2 is fail to reject. So in this case, the probability of mistakenly rejecting, no, because we have to fail to. It's the probability of failing to reject, nope. The probability of mistakenly rejecting, nope. The probability of failing to reject a false null is 4%. And the reason I know it has to be false is because remember, these are all conditional probabilities. So a type 2 error is given the null is false, we failed to reject it, or we failed to reject it given the null is false. So that makes that a type 2 error definition. All right, number 58. A government statistician claims that the mean income level of families living in a subsidized housing is 9,250 with a standard deviation of 2,575. A reporter plans to test this claim through interviews with a random sample of 50 families. If she finds a sample mean more than 500 different from the claimed 9,250, she will dispute the claim. What is the probability that the mistakenly reject a true claim? I need to pause this for a moment and reread this. All right, so they say, what is the probability that the reporter will mistakenly reject a true claim? That is the definition of a type 1 error, which is alpha. So they're looking for our alpha, or that's also very similar to the definition of a p-value. So essentially, in this case, they're asking us to run the test. So in this case, our test is going to be the null is that 9,250. The alternative is going to be that it's not equal, the mean is not equal to 9,250, but she's going to actually reject if it's more than 500 different. So basically, if it's as low as 8,750, or if it's as great as 9,750. So if I'm drawing a picture of this, because I think this will help more than anything else, my claim mean is 9,250. My rejection zones are if this is 9,750 or more, or if this is 8,750 or less. So it doesn't matter which one I choose. I can choose one or the other and run it. So I'm going to run a stats test t-test based on 9,750. So stats, test, t-test, statistics. My mean is 9,250. My standard deviation is 2575. My sample is, my X bar, I'm sorry, I used the wrong. This should be, it doesn't matter which one I choose, I'm going to use this one, 9750. My standard deviation is going to be 2575. And my sample size is 50, more than 500 different. That tells me this needs to be a not equal. So I need to have a not equal here, not a greater than. It needs to be a not equal. So I end up getting a p-value of about 0.175. So I ended up getting a p-value of about 0.175. This is the closest answer. So the answer to this one should be letter C. All right, the question came up is, could I use the z-test? And I probably should have done so in this case. So I just kind of got called out by one of my students because they told me, they basically said the standard deviation is known to be 2,575. So let's go ahead and run that as a z-test. And I do believe that that is actually the correct thing to have done in this case. And so we'll go back and we'll rerun this. And this is one of the great things about having smart students is they don't allow me to continue to make mistakes. That's good. And so once again, we're about 17% being the closest answer. And I would have said that this is a better answer than the way I did it initially. So the question was, could I have used 8,750? And as long as I used the not equal, I would be fine. Now, if I'd used a less than or greater than, I would have needed to make sure I went 2 times the probability that Z is less than 8,750. Or if I had done just a greater than here, it would have been 2 times the probability. And the reason is because it was difference. So I could have used either one and that would have been correct. It is hypothesized that players lose an average of $110 during an evening at a blackjack table in a Las Vegas casino. A government tax collector believes the true mean loss is greater than this claim and plans a hypothesis test on a random sample of blackjack players. Suppose the tax collector is correct for a sample of n is 100 and a significance level of 0.05. For which possible actual mean losses will the power of the test be the greatest? Okay, so first off, let's write down our claim. The claim is this. The alternative in this case is greater than 100. I'm going to draw a picture. Here's where we are. Okay, so power increases the farther you get away from the mean. Power increases the farther you get away from the mean, as long as you're following the direction of the inequality. So I need to follow the direction of the inequality, which means this goes away. I don't care if it was 85 or whatever. It's going to be, as I get moved this way, because I have to move in the direction of the inequality, power increases. And it goes like this. If I claim that the test average was a 90, would you be more likely to reject my claim if your sample showed 85 or if your sample showed 45? Well, obviously you'd go sample of 45. I'm definitely rejecting Mr. Spencer's claim. So the farther it is away from the mean, the claim, the more likely we are to reject. So same thing, more likely reality is farther away from what we claim, the more likely we are to reject. but you must be in the direction of the inequality. You must be in the direction of the inequality. Had it been not equal, it could have been in either direction, but since it was greater than, we needed to be above 100, and we wanted to be as far away from 100, but as far above 100, because that would be in the direction of the inequality. It was pointed out to me that I used 100. I should have used 110. So this should have been at 110, not 100. Once again, I needed to be as far away from 110 as possible. Well, you're probably sitting there going 95 farther away, but it's in the wrong direction. So the one that's in the right direction, that's as far away as possible, is 120. Okay? And I apologize, it should have been 110 and not 100. All right, on number 60, consider a hypothesis test, mu is 58 versus mu is greater than 58. Which of the following choices, the significance level and sample size, results in the greatest power of the test? So what helps power? Well, power goes up as alpha goes up. Power goes up as alpha goes up. Power also goes up as n goes up. Power goes up as beta goes down. So we're going to want the largest alpha, the largest n, the smallest beta. Well, my largest alpha is 0.05. So that gets rid of this one and this one. And then my largest sample size is 25. So in this case, I'm going to want answer C, because power goes up as alpha goes up and n goes up. They didn't give us any information on beta, so we didn't have to worry about it. The power goes up as alpha goes up and the sample size goes up.